Hi everyone, I am Ritika from Department of Biomedical Engineering, Erode Singundar Engineering College. Today I am going to present my seminar on improving EEG based brain computer interface performance through powerline interference removal. Now let me begin with a brief introduction to EEG. Introduction: Electroencephalography or EEG is a technique used to record the electrical activity of the brain. These EEG signals are very weak and are easily affected by an external disturbance. Because of this, noise removal becomes a critical pre-processing step. Among different types of noise, powerline interference is one of the most common problems in EEG-based system. Next, I will explain overview of brain-computer interface. A brain computer interface of or BCI is a system that converts the brain signals into control commands. It allows users to control external devices without any muscle movement. EEG is widely used in BCI because it is non-invasive, safe and low cost. For accurate BCI performance, clean EEG signals are required. To understand why noise affects BCI, let us look at EEG signal characteristics. EEG signal have very low amplitude, usually in microvolts. They consist of frequency bands such as alpha, beta, and gamma. These signals are non-stationary and highly sensitive to noise. Even a small interference can affect the EEG analysis and classification. Now let us understand what noise actually means in EEG. What is noise in EEG? Noise is any unwanted signal that gets mixed with the original EEG signal. It reduces the quality and reliability of EEG recordings. Common noise sources include eye blinks, muscle movements, electrode movement, and powerline interference. These are the noise in ECG. Next, we are going to discuss about powerline noise. What does mean by powerline noise? Powerline noise is electrical interference caused by the mains electrical supply. In India, the mains frequency is 50 Hz, while some countries it is 60 Hz. This noise appears as a continuous sinusoidal disturbance in EEG recordings. Next, let us see how this powerline noise enters EEG signals. Source of powerline interference. Powerline noise can be enter EEG recordings due to nearby wiring, charges, fans, lights, computers, and poor grounding. Long electrode wires can also act as like antennas and pick up interference. It is a very common noise in EEG. Powerline noise is common in EEG. EEG electrodes capture very small brain signals, while the environment contain the strong electromagnetic fields due to induction effects. EEG system easily pick up 50 Hz signals. Effect of powerline noise on EEG. Powerline noise reduces signal clarity and hides important brain rhythms. It distorts waveform patterns and affects time domain and frequency domain analysis. This reduces the accuracy of EEG interpretation. Now let us understand its effects on BCI performance. Powerline noise on BCI performance. In BCI system, powerline noise reduces the feature extraction quality. It creates false frequency peaks and increase classification errors. This decreases real-time control accuracy and reliability. So next, how do we identify powerline noise? Identifying powerline noise is very important because it can create various misclassification. Powerline noise appears as respective oscillation in EEG waveforms. It produces a saw peak at 50 Hz in the frequency spectrum. It usually affects the multiple EEG channels. To remove this noise, we use a notch filter. A notch filter remove a narrow range of frequencies. In EEG processing, it is used to suppress powerline interference while preserving useful signals. Now let us see how a 50 Hz notch filter works. Notch filter is designed to remove noise exactly at 50 Hz. It reduces the powerline interference and improves signal to noise ratio. This filter is usually used in EEG pre-processing. Next, I will explain its working principle. Working principle of 50 Hz notch filter. First, the EEG signals are recorded from the scalp using electrodes. Next, the power line interference is added to the signal. The notch filter blocks the 50 Hz component, producing the clearer EEG signal. Next, let us see where this fits in the BCI pipeline. BCI signal processing pipeline. The BCI pipeline includes ECG acquisition, pre-processing, feature extraction, classification, and device control. Notch filtering is performed during the pre-processing stage. Limitation of notch filter. Notch filters may remove useful EEG information near 50 Hz. Improper proper design can distort signals. They may not remove higher harmonics like 100 Hz. Other methods to reduce power line noise. Other methods include proper grounding, shielding, short electrode cables, good electrode contact, high quality amplifiers, and adaptive filtering. These are the methods to reduce the power line noise. Applications. Power line noise removal is important in motor imaginary BCS, P300 systems, SSVEP system, medical EEG monitoring, and brain research. Finally, power line noise is a common EEG disturbance caused by mains electricity. In India, it mainly occurs at 50 Hz. A 50 Hz notch filter is effectively removes this noise and improves EEG signal quality and BCI performance. Thank you for your attention. Thank you.